So now that we know what the sampling distribution is, let's go through a few problems so we can see how it's used. One way that statistics is used a lot is to predict voter behavior. So in this example, we're looking at a referendum, and a referendum is when individuals, citizens, vote on the passage of a law. So maybe it's the passage of a property tax or a local mandate on recycling, and that's what we're looking at here. Before the vote, a local newspaper polled 358 voters to predict whether or not the mandate will actually pass. Suppose that the mandate in reality has support of 53% of the voters. We want to figure out what's the probability that the newspaper's sample actually leads to predict defeat. So what this is asking is it's taking into consideration the fact that samples vary. Some samples are going to be less than this true proportion, and some are going to be more. And so what this is asking is the newspaper's sample lower than this true proportion? So one way to write that is the probability that the newspaper's proportion, so here I've denoted it as Pn, but really I would write this as P hat to denote a sample proportion. We want that to be less than 50%, because something less than 50% would mean that the referendum got defeated. We can convert this to a z-score then by just standardizing it, subtracting the mean, and dividing by the standard deviation. So the mean again is the true proportion, and the problem gives us the true proportion of voters who support the bill. That's 53%. So our true P here is 0.53. We can use this 0.53 then to generate our standard deviation. Our standard deviation is just the square root of P times Q, where Q is just 1 minus P. So that's how I got 0.47. And then I divide by the sample size. Here they've surveyed 358 people, and so that is my sample size. When I calculate that out, I get a z-score of negative 1.13. So saying that z has to be less than negative 1.13 is equivalent to saying that the newspaper's sample is less than 50%. I can then look up this proportion or this probability on my z-table or using a z-calculator, and when I do that, I get a probability of 0.1292. So that's my answer to this question. So the probability that the newspaper gets it wrong and predicts defeat is really pretty small. It's not unreasonable, but it's still quite small. This possibility of getting the outcome wrong in a referendum or in voting behavior happens a lot to statisticians. We saw it happen in the last election, where most statisticians were actually predicting Hillary to win the election. But the sampling may have been too small to get an accurate prediction, and they were actually predicting a close race through the whole thing. So these are the steps that we went through in that word problem. The first thing that we want to do is determine the true proportion or the mean for the sampling distribution. This is often the hardest part. Figuring out what is your sample proportion and what is the true proportion, that's the most difficult part in problems. Once you have that, it's pretty easy to calculate the sampling mean and the sampling standard deviation. The third step is determining the standard you are comparing the mean to. That is, what number do we put first? That's usually our sample, and then we put the true proportion second because that's the sampling mean. Once we have that standard, we can calculate the z-score for that standard, and we can find percentiles and probabilities of seeing that z-score. So let's work through another problem so you can see how these steps work out. Another instance in which statistics and probability are used are often in manufacturing to determine quality assurance. Here we have a packaging plant or a food processing plant that accepts truckloads of apples. However, if more than 5% of the truckload is bad, it's going to reject it. Now they can't look at the whole truckload. That would just be too time-consuming and very costly. So instead, they just pick 125 apples to select and examine it to see if there's bruises, discoloration, and other defects. And so we're going to look at that sample to see whether or not that sample meets this 5% criteria. So let's suppose that we know what the true proportion of apples on the truck that do not meet the standard is. Let's say that we know it's actually 9%. This 5% is just like our criteria for rejection, whereas the true proportion of bad apples is 9%. We want to know what's the probability that the shipment will be shipped anyway. That is, the sample that we've chosen is less than 5%. So we're choosing apples from this truck where 9% of the apples are bad, and we're only selecting 125 of them. So some of our samples might be less than 9%, some of them are more than 9%. We want to know, is one of our samples that we select so low that it's less than 5%? So another way of writing this question is that we're trying to find the probability that our sample from this truck is less than 5%, because less than 5% means that it meets this 5% criteria and the truck can be shipped. So we can standardize this sample with the z-score, assuming a mean of 0.09, because we know the true proportion of bad apples is 0.09. And then we can find the standard deviation. The standard deviation of the proportion is just the square root of the proportion of good apples, the proportion of bad apples, divided by the number of apples that we've sampled. So this is our standard deviation, and this whole thing gives us our z-score, which is negative 1.5265. We can get from this then our probability. Again, you just get this from your z-table or your z-calculator, and that's going to be a probability of 0.0594. So really what this problem is getting at is this. We have a truck with a lot of bad apples in it. It doesn't meet the criteria of 5%. But we can't check the whole population, and oftentimes we don't know this true population. So what we do instead is we select samples to test for bruising and discoloration. So if that sample is less than 5%, it gets shipped, even though the true proportion may not be actually less than 5%. The probability that you ship a truck that has bad apples like this anyway is quite low. It's 0.05 or 0.06 if you round up. So that's a really small probability that you would accidentally ship a truck that violated this 5% condition. So that's how you would apply the theory of the sampling distribution to some word problems. And then eventually, again, you use the normal model, which is why it's so important to learn how to use those z-tables and the z-calculators. In the next set of videos, we're going to move on to developing confidence intervals, where we can look at ranges of proportions and where we think that true proportion might lie. As I mentioned previously, oftentimes we don't know where the true proportion is, and so the confidence interval will give us a range of proportions where we think it might be.